Find the inverse of the following matrix if it exists. What do you mean by if it exists? You know, we have done that inverse of a matrix or a matrix is invertible provided it is, determinant A is non-equal to 0, provided it is non-singular. It will exist if the given matrix A should be non-singular. By non-singular you mean determinant A is not equal to 0. A matrix is said to be singular if determinant A is 0 and non-singular if determinant A is not equal to 0. And what is the definition of A inverse? Definition of A inverse is it is 1 by determinant A into adjoint A. It is also clear from here that in case determinant A is 0, so 1 by 0 will be meaningless. So it won't work. So let us first find out determinant A and then we'll substitute in this relation 1. How do you work out determinant A? What is it? The matrix is 2 minus 2 and 4, 3. So the value of determinant A will be 2 into 3, 6 and minus plus 8. So you get 14. Determinant A is 14. Keep it here. And now let us work out adjoint A. How do you define adjoint A? It is the transpose of corresponding cofactor matrix. That is each element to be replaced by cofactor C11, C12, C21, C22 with the proper signs plus, minus, plus. So it will be transpose of, now let me write directly, the cofactor of this element 1, 1, 2 will be the opposite number 3 with the same sign, so it will be 3. For 3 it will be 2 with the same sign, 3, 2. For 4 it is negative 2 with the change sign, so it will become 2. And for negative 2 it is 4 with the change sign, it will become, negative 4. So 3, negative 4, 2, 2 and don't forget to take the transpose. Taking the transpose, you get adjoint A, the element of first row 3, negative 4 will go to the first column and 2, 2 to the second column. So this is the value of adjoint A, 3, 2, negative 4, 2. So finally, now applying the definition of A inverse is defined as 1 by determinant A into adjoint A. That is 1 by, we have worked out the value of determinant A as 14, so 1 by 14 and adjoint A is the matrix 3, 2 minus 4, 2. So this is the value of A inverse. If you like, you may divide each element by 14, it being 1 by 14, or you may leave it like this. Find the inverse of the following matrix. The given matrix A is minus 1, 5, minus 3, 2. What is the definition of A inverse? It is 1 by determinant A into adjoint A. So we need to find determinant A and adjoint A. If determinant A is non-zero, then only we should proceed further. Otherwise, the inverse will not exist. So let me first find out determinant A. That is determinant negative 1, 5, negative 3, 2. So it is negative 2, you multiply, you get negative 2, negative 1 into 2, negative 2 and minus plus 15, negative 5 into negative 3, negative 15 and minus plus. So you get 15 minus 2, that is 13. So finally, at least we have got the value of determinant A. And what more you want? We want the value of adjoint A also. So let us now find out this way, adjoint A. It is the transpose of a matrix obtained by replacing each element by corresponding cofactor. That is transpose of C11, C12, C21 and C22. So we'll find the value of cofactors. Keep in mind the sign convention plus plus with the corresponding minus. Now for C11 you delete the row and column through -1, take the opposite number 2 with the same sign, so it is 2. And similarly for C22 take the opposite number which is -1 with the same sign, so you get at least the diagonal elements we can obtain simply by interchanging them. Now what about the other? This is about the main diagonal. Now about the other diagonal element, that is C12. What is the opposite number of C12? That is of 5, negative 3, and that is to be, change the sign. For C12, change the sign. So negative of negative 3, it will be plus 3. And then similarly for C21, the opposite to negative 3 is 5 with the change sign, so it is negative 5. Don't forget to take the transpose. Yes, it is transpose. So finally, the value of adjoint A is transpose of the matrix. So the elements of the first row 2, 3 you write in the first column, and that of second row minus 5, minus 1 you write in the second column. So now we have determinant A, we have worked out the value of adjoint A, so we can say yes, A inverse is, again write the definition, 1 by determinant A into adjoint A, and fill the numerical values. That is 1 by, what is the value of determinant A? 13, and we worked out adjoint A as 2 minus 5 and 3 minus 1. So that is the value of A inverse. Find the inverse of the following matrix. What is the definition of A inverse? It is 1 by determinant A into adjoint A. Okay, let me first work out the value of determinant A. That is 1, 2, 3 determinant, 1, 2, 3, 0, 2, 4, 0, 0, 5. We can expand it with respect to any one row or column. It is convenient to expand to find the value of determinant along C1. Why? Because already it has got 2 zeros. So it will be, the value of determinant A will be 1 time, delete the row and column through 1, you get 2 into 5, 10 minus 0, and other 2 elements are already 0, minus 0, plus 0. So what is the value of determinant A? Easily we got the value of determinant A as 10. And now work out the value of adjoint A. How do you define adjoint A? Adjoint A is defined as transpose of the matrix of the same order obtained by replacing each element by corresponding cofactor. That is transpose of C11, C12, C13, C21, C22, C23, C31, C32, C33. So we'll work out all these cofactors, which are the minus impose the proper sign, that is plus, minus, plus, minus, plus, minus, plus, minus, plus. So we'll work out the value of these factors by deleting the row and column through that particular number and impose the proper sign. So and take the transpose of it. So I leave this time for you to find out the value of cofactors, and transpose I'll take myself. If you work out the cofactors will be C11 will be 10, 1, 2 will be 0, 1, 3 will also be 0, and the elements, the cofactors in the second row will get minus 10, 5, 0, 2, negative 4, 2. Take transpose of it to get adjoint A. So element of the first row, that is 10, 0, 0, you write in the first column. That of the second row, that is minus 10, 5, 0, you write in the second column. Minus 10, 5, minus 4. Minus 10, 5, 0, you write in the second column. And elements of the third row, 2, minus 4, 2, you write in the third column. So this is adjoint A. So once you know adjoint A, what is the value of A inverse? The formula for A inverse is 1 by determinant A into, now it is mere a matter of into adjoint A, replacing the values. How much you calculated determinant A? 10. So it is 1 by 10. And what is the value of adjoint A? It is 10 minus 10, 2, 0, 5, minus 4, 0, 0, 2. So 1 by 10 times this matrix, that is the required value of A inverse.